Lab 2 quiz is going to be later today, around 11. Demos are starting tomorrow. Hold it, Tuesday, June 1st. That's not Tuesday. I don't know what this means, but lab demos start this week, I think today. So this should say 31st of May. Lab 3 is posted, due on Sunday. We'll finish talking about that, I hope today, or not today, for sure on Thursday. There is another help session on interrupts, the topic that we'll get to starting today. And then there's homework that I posted a while back. It's on using a timer system for the 3-color LEDs, which we talked about in a lecture. That is due next Thursday, not this Thursday. Please, if you send me an email, please put 4744 somewhere in the subject. It makes it something that I look at early in all the emails I get. And tell me what the subject is about. Okay, any questions before we get going? We got a lot of things to cover today. Any questions? Okay, again, we will have a quiz around 11. Again, don't forget, I want your cameras on. Giovanni and Yang, thank you. Okay, same with Matthew. Okay, let's start the lecture. We're going to first talk about the include file a little bit, and actually I'm going to open it so we have it. We'll open it one way, and let's see, go to this. For that to come open. Might as well open the example we're going to do later today. And get to the include file that way. This right here is the include file. Okay, actually, let's just make this the whole thing. Okay, so the include file, we're going to find it's going to become more and more useful the more we get into the configuration registers that we deal with for all the peripherals. And once we get to C, it'll even be more powerful because the auto-complete will work a lot better. Okay, so let's talk about, we've seen some of these already, something called bit masks and bit positions and group configurations, but we'll look at that in more detail. So lots of equates in this include file. In fact, it's almost all equates. In fact, XL and XH and ZL and ZH, all of these are defined in the include file. They're not defined anywhere else. Let's see if I can find them. There it is, right here. They're defined in the include file. They're not defined in the language. They're defined in the include file. But anyway, some other things. Let's look at this SRAM. And well, we've talked about the internal SRAM, right? It starts at address 2000. That's in the include file. The size of this, it goes from 2000 to 3FFF. So the size is also X2000. And the end is 3FFF, which is 2000 plus 2000 minus 1. Now they could have just as well said start SS internal SRAM start plus internal SRAM size minus 1, which a better programmer would have done. But people that wrote this, they're not perfect. It also shows you here this external SRAM has nothing to do with SRAM. This is external space that's available in data memory. Okay. And it's got the same kind of things for other kinds of memory. EEPROM there, the boot section, application table, things that we've talked about, program memory. etc. Let's go back here. The CPU underscore stuff. Oops. All of these are defined in the include file. So the ones that you used in lab 0 or lab 1, ramp Z, and the ones that you use when we start with any subroutines, CPU underscore stack pointer low and high. And if you ever need the status registers, there they are also. And then bit masks. Let's look for TC 0 clock. Okay, there's bit mask and bit positions. The bit mask, like this one, clock select, I guess we've been doing prescalers, the prescaler, so it's maybe not one to see, but let me just show you select 2. There's this notation that's used in this include file, a bunch of these shifts. That's saying shift the number 3 1 bit to the left. What happens when you're out of it for a couple days? Shift, yeah. And so this bit mask shifts. This is the way we do. We always do these things. So there is a configuration file that has certain bits. If those bits are in position starting with position 0, 1, 2, 3, then there's no shift. If they're in positions 1, 2, 3, for instance, we'll shift it 1 bit. If it's in 2, 3, 4, we shift it 2 bits. Okay, and we'll see this again in some examples coming up. And so that's bit mask and bit position, same kind of thing. But bit position says, what position is a bit in? For single bits, you say, is it bit 0, 1, 2, 3, 4, 5, 6, 7? So these are the things we'll see mostly. And so I've got an example here, which is not, I don't believe these are in the include file. Let me kill this. These are just something I made up because this is what the status register looks like. Status register looks like the carry bit, the 0 bit. So I said, okay, let's use bit masks. If I want to see where the carry bit is, I want to get rid of everything else except the carry bit. If you say the 0, 1, if you and this bit mask with the status register, the only thing that's left is what's in the carry bit. So it's called a bit mask. So if the carry bit is 0, the whole result of this is 0. If the carry bit is 1, then the result is not 0. And the same with the 0 bit mask. Now we have a 1, that's a 1 in bit 2, in bit 1, and we AND that with this, then if the result of this whole register with the ANDed operation equals 0, then the 0 bit is 0. And if it's equal to anything other than 0, then the 0 bit is true. Okay. And then for bit position, well, the carry bit is in position 0, and the 0 bit is in position 1, and this I bit is in position 7. So that's a bit position and a bit mask. Again, these I don't believe are in this include file at all. And then we can talk about the RGB LED that we've already dealt with. So here I've got red LED bit position. I could define this. The red LED was port D bit 4. The green LED was port D bit 5. Blue LED is port D bit 6. And so for instance, now this is much clearer to read. I can say, okay, there's some bit, I don't know what bit it is. It's the red LED bit. Well, put a 1 in that bit, shift it that many bits over. So if this is a 4, it's going to shift that 1 4 bits over. So there's a 1. When we shifted 4 bits over, there it is. And so in bit 4 will now be a 1. And then we can output this out clear. So we're going to clear that bit, turns on that LED. Same thing here with green LED. So these bit positions make your code clearer, and it's something that the include file does all the time. Okay, so for the clock dividers, which you've used in your timers, these are what's called group configurations. The group configurations, so this is the control A register, for some particular timer counter. And we see they're all in the low 4 bits. Those bits that matter are in the low 4 bits. So we don't have to shift anything. That's why we have all these shift zeros. So if we put a 0 in these bits, well, the timer's off. We put a 4 in these bits, the number 4, that's a divide by 8. So we don't have to shift anything. Now, if these bits, these things were not here, but over here, all of these shift zeros would be shift 4s. Okay. We're in another, I think lab 4. I think it's lab 4, or no, lab 5. We're going to learn about serial communication, asynchronous serial communication. And there's a bunch of different things you can do for asynchronous serial communication. There's a bunch of modes and values that can get set up. And here's a control register associated with this, USART. Okay, and there's 4 different bit fields, 4 different fields of information. And each of these, you're going to set some values. So for instance, there's this thing called C mode. So this says, am I going to use what's called asynchronous serial, synchronous serial, and there's some other modes. So in the include file, there's this thing called USART C mode asynchronous group configuration. These are group configurations. In the manuals, you'll see these group configurations. In fact, let me open that chapter, Control C. So this is showing us exactly what I'm looking at, what I was looking at. Let's get rid of that. But now let's see what this means. C mode, there's a chart on the next page about C mode. C mode, okay, if you put 0, 0 there, it's asynchronous serial. That's called a group configuration. So the name right here, so first it says USART, C mode, that's the name of the group configuration. And then what's the value for that group configuration? It's asynchronous. And then there's another one called synchronous, and there's another one called these two, all in this thing called C mode. Similarly, there's this thing called P mode, that's called parity mode. And for parity mode, I've got an example here. Oh, no, let's skip that one and go to character size. Character size is down here. Character size is, could be bits, I think it's, let's find it. 5, 6, 7, 8, or 9 bits. And these are the different values. So this is the group configuration itself. So the word 5 bits or 6 bits or 8 bits. And character size is the name of the group configuration. And let's go back down. Well, let's go back here. And because character size is right here, notice we don't have to do any shifting. But this C mode thing is way up here. And so we have to write the number that we wanted to put here actually is 0, but then we're shifting it 6 bits over to put it in bits 6 and 7. By default, it would be in bits 0 and 1. Now, if we did like synchronous, instead of asynchronous, we put a 0, 1. So this would be a 0, 1 shifted 6 bits over. Here we've got parity mode. Parity mode is way up here. So it looks like bit 4, so we're going to shift it 4 bits over. Shifted 4 bits over, and we wanted parity mode to be odd, so we can look at that table. Parity mode, group configuration, odd is 1, 1. Okay, get a feel for this? So the idea of this is if you use the include file, you don't have to look at those tables. But to use the include file, you have to kind of know how the systems work. What are the named group configurations? Now, again, when we get to C, you're going to see that they'll all come up automatically when you put, for instance, Control C, you'd see all of those group configurations. You said USART C0, Control C. There'd be choices for all of those group configurations. But then I've got this SB mode, that's another group configuration. Okay, so finally, what can you do then? I know that for this Control C, all of those values have to be set. And so then we have this nice little trick. I don't know if it's a trick, but once you use these group configurations, you OR them all together. Because effectively, we've got some bits that'll be in these positions, some bits that'll be in this position, some bits in this, and some bits in this. And if we have the C mode, there are no bits going to be in any of these. They'll all be zeros. And if we had P mode, there'd be some bits in these two positions, but all of the rest would be zeros. So you can OR things, and that puts them all together. So all we do is all of these group configurations, these four, I just OR together. Doesn't matter the order because ORs are commutative, associative. Doesn't matter. And so again, this is something that you'll be using hopefully soon, but once you get to C, you have to use it. It's too inefficient not to use it. And I'll require you to use it because it makes your code 10 times easier to read. You make your code easy to read, your pies are more likely to give you good grades. Even if you miss something, at least they'll understand why you missed it. Instead of having to look up all the values, if you just put 1, 0, 0, 1, 1, 0, 1, 0, and if you just put that in the Control C register and something's not working, the pie's got to look up all those things to see why it doesn't work. But if you use the group configurations, they'd say, aha, you used P mode odd when you should have used P mode even. It's really easy. Makes your code easier to read, easier for you to edit. And again, make sure you remember, in your practicals, you will have your code available. And what's going to happen in the first practical, the second practical, the same. I'm going to take a variation of the program you write in lab. I'm going to say, okay, for instance, if there was serial there, instead of doing even parity, I'd say do odd parity here. Instead of 8 characters, I'd say do 6. And if you use the group configurations, boom, it's going to be easy to change. And if you didn't, then you're going to have to reinvent the wheel. Okay. Okay, so that's it with group configurations.